Hello everyone. Today we are going to discussing about the Buckingham's pi theorem, very important for the examination point of view. Okay, first we are going to state this Buckingham's pi theorem. This Buckingham's pi theorem states that here it is telling that if there are n variables, it means it including both independent as well as the dependent variables in a physical phenomenon, and if this variable contains m fundamental dimensions mlt, then the variables arranged into n minus m dimensional terms, each term is going to call as pi term. Okay, here three key points are very important. One is the total variable, that is going to call as an n variables, that is independent and dependent variable, and the variable contains m fundamental dimensions. M fundamental dimensions means this m is equals to 3 now. Then the variables arranged into n minus m, that is going to call as a dimensionless term. See, just I'm going to elaborate this problem. Actually, in previous case, when we solved the one problem on the pendulum problem, that is the problem number 2. We solved one pendulum problem. That is what the time is function of the length and acceleration due to gravity. We solved this problem. So here time is function of L comma G. So I will show that problem right now. Hmm. See here, this is the problem we solved. That is for example, this one I'm taking. Time is a function of what? Length and acceleration due to gravity. This problem is solved. Here, the total number of variables. These are the things I already explained. One more time I explaining the same things right now. See here, the total variables are three. Total three variables. This is 1, 2, 3. Time, length, g. Out of total variables, this is going to call as an n variables. It includes independent plus dependent variable. This time is going to call as an independent variable, and this one is going to call as an dependent variable. Totally, the now n becomes 3. N becomes 3. Next, m means what? M means the total number of fundamental dimension. What is the unit of dimension of time? The dimension of time is seconds, so that is unit is t. Next, the unit of length is meter, that is length, L. And the acceleration due to gravity, g, that is what? Meter per second square. So I can written as lt minus 2. We know that where m means the fundamental dimension, that is m comma l comma t. Here the fundamental dimension is how much fundamental dimensions will be there? Only two dimensions is there. Lt is there, not mlt is there. So m becomes 3. M is equals to 3. Now in every equation you have to find out the n, then how many dimensions is there, how many dimension terms will be there, dimensions will be there, like mass, length, time, mlt, like these three different dimension terms will be there. That one have to be count. Here there is no mass, there is no m term, mass term. Only you having the l as well as the time. So the m becomes here 2. M becomes 2 here. The m value becomes 2 here. So n minus m is now going to call as the pi term. The pi term becomes what? N minus m is 3 minus 2 is pi become 1. So this is the Buckingham's pi theorem. Now you are very know about what is meant by the independent variable and what is meant by the dependent variable. Later, how to find out the n is total variables. Then writing the dimensions to all the variables, count how many fundamental dimensions is there. Fundamental dimensions means these things, mlt, that is used in the fluid mechanics. Find how much fundamental. Most of the problems you having all the three, but this is a very simple problem, so it is having only the two dimensions. So the m is 2, then n minus m is going to call as an pi term. Now later pi is equals to 3 minus 2, pi is equals to 1 term. This is the definition actually. Here it is telling that, see, next they are telling that let x1, x2, x3, etc. xn are the variables involved in a physical problem. See, the same way it is telling that x1, x2, x3, etc. are the variables involved in one physical problem. Let x1, see how the t I taken, let x1 be the dependent variable. Then remaining things, if x1 is the dependent, like for this example, remaining variables is going to call as an independent variable. Then this x1 is depend upon on complete these things. X1 is depend upon all these things. So we can write mathematically as x1 is equals to function of x2 comma x3 comma etc. xn. Similarly, how we written here, the independent variable is function of the dependent variable. In the same way, we have to write that. This equation 1 I can also written as function of x1 comma x2 comma x3 comma etc. xn is equals to 0. Xn is equals to 0. I'm going to call this is equation 2. See, the equation 2 is dimensionally homogeneous equation. It contains n variables. N variables. If there are m fundamental dimensions according to the Buckingham's pi theorem, equation 2 can be written as number of dimensionless groups of pi terms. See, what is telling that means the same thing what the things we did here. The n variables, total n variables, then find out the m variables, then n minus m, you are getting the pi terms. You're getting the pi terms. The same thing. This para is going to explain this procedure. This is the procedure. This is the actually this one is the definition. This is the definition, and these are the steps how to solve the problems. When you are going to solving the problem, then it is very simple to understand. Then we can written as f1 is function of pi 1 comma pi 2 comma pi 3 etc. pi n minus m is equals to 0. Next, each pi term contains m plus 1 variable, where m is going to call as an repeating variables. Where m is called the fundamental dimension, it is also called as a repeating variables. Let in the above case x2, x3, x4 are the repeating variables. If the fundamental dimensions m is equals to 3, the each pi term can be written as like that. Pi 1 is equals to x2, x3, x4, x1. Then x2 to the power of a2, x3 to the power of b2, x to the power of x4 to the power of c2, x5. Later you can write like that, or you can write this one. See, these are the steps completely. This is the step 1 2 3 4, like it is the stepwise is there. And now of course it is not possible to understand very easily. When we are solving the problem, you can understand very easily. Here the student should know about what is meant by the n, what is meant by the small letter n variables, means total variables. It containing both independent and dependent variable. In given problem, how many dimensions, the fundamental dimensions are there, like mlt, all mlt terms are there, only length and time is there, or only the time is there. You have to find out the total number of dimensions. Then n minus m you are going to obtain as the pi term. Okay, how many pi term will be there in this problem? In this problem, the pi term will be the 1. Suppose the n is 6, total number of variables is 6, then what will happen? N minus m is equals to pi. So 6 minus 2, suppose in this problem, okay, I will take m is equals to 3. m is equals to 3, n is equals to 6, then pi term become 3. Now suppose if n is equals to 7, pi become total 4 terms will be there, 4 pi terms. This pi terms is nothing but that is the dimensionless term. This pi is doesn't having any doesn't having any dimension, means m to the power of 0, l to the power of 0, t to the power of 0, there is no dimension, there is no any units, that is going to call as a dimensionless. Okay. This is the procedure. When you are solving this one, you're going to understand. See, one more important. Right now, you know what is meant by the m and what is meant by the m. N minus m, you are going to obtain as the pi terms. Okay, just I will explain. That is, if it is the 6 and 3, pi becomes 3. If 6 minus if n is equals to 7, 7 minus 3, pi becomes 4. Likewise, I explained. One more very important, that one, that is, this is m is going to call as the fundamental dimensions, and also it is going to call as an what, repeating variables. It's also going to call as an repeating variables. This is one more very important concept, understanding the repeating variables. You have to choose the repeating variables in the given problem. You have to choose the one repeating variable in the given problem. See how to choose the repeating variable. Here are the some rules and regulations is there. Very one important setup is the repeating variable. The repeating variable should not be a dependent variable. One thing, once again, the same thing we are going to solving the problem, we are going to understand the repeating variable should not be a dependent variable. Later, the repeating variable containing three properties. Try to understand it. Contains the three properties. One is the geometric property, and another is the flow property, and another is the fluid property. Geometric property means geometric means it may be a length, diameter, height, area, like that. That one is going to call it the geometric properties. And next is the flow properties. Flow properties, it may be a velocity, it may be an acceleration, it may be a what, angular velocity, angular acceleration. That one you're going to call as a flow property. Next, the fluid property. In the first unit, we discussed a lot of the fluid properties like density, specific gravity, viscosity, dynamic viscosity. That is going to call as a fluid properties. See, in the problem, you have to choose the repeating variables like that. One should be a geometric property, another should be a flow property, and another should be the fluid property. The geometric properties, it may be a length, diameter, height, and what? Next, the flow properties. Flow means it moving. That may be a velocity, that may be a like acceleration, etc. Fluid properties, I already mentioned, it may be a mu, rho, nu, specific weight. Okay, these are all related to the fluid properties we studied in the first unit. One is the repeating variable. At any cost should not be a dependent variable. The repeating variable containing a three terms, that is what, one is the geometric property, another is the flow property, and another is the fluid property. And next, the important rule is the repeating variable should not form a dimensionless group. Okay, it should having a dimensions. And the fourth one, the repeating variables together must have the same number of fundamental dimensions. No two repeating variable should have the same dimensions. Okay, no two variables should have the same dimensions. Suppose I already mentioned that one is the geometric property, and another is the flow property, another is the fluid property. While you taking these dimensions, the two repeating variables should not have the same dimensions, should not have the same dimension. Likewise, you have to be choose. Okay, likewise you have to be choose the two dimensions. The two repeating variables should not have the same. Suppose for example lt minus 1, here also lt minus 1, that is not to be taken, should not be taken. That is going to be mentioning the point number 5. See, in most of the problems, likewise you may get that one. Likewise, Likewise, you may get like this. How it may be a diameter, velocity, density, or it may be a length, velocity, density. Means like length, velocity, viscosity, or diameter, velocity, viscosity. Likewise, in most of the problems you are going to get. We will solve one problem, then you will understand very properly. Okay, we will solve one problem. Actually, this is the problem number is 12.7 in the textbook. Okay, 12.7 in the textbook. Now we will solve. If you are understanding one problem, it is easy to solve the remaining problem. So understand very carefully. Here it is telling that what the resistance force R of a plane supersonic plane during flight can be considered as dependent upon length of the aircraft. Dependent, see, the resistance force R of a supersonic plane during flight can be considered as dependent upon the length of the aircraft. This is the one. Actually, this is the dependent variable. Now these are become the independent variable. And next is depend upon velocity v, air viscosity mu, air density rho, and the bulk modulus of air, the k. Totally, how okay, express the fundamental relationship between these variables and the resisting force. We will go the step by step, one by one process. First is what the step one. In the step one, write this one. The resistance force R is a function of, it is giving length, velocity, mu, and rho, and k. Okay. Now you count how many variables are there in this one. This one I can also written as, it can also be written as according to the Buckingham's theorem. I can also, this one is also I can written as the function of r comma l comma v comma mu comma rho comma k is equals to 0. Now you tell me the n total variables, how many total variables are there in this one. I can written as n is equals to total number of variables 1 2 3 4 5 6. Now n becomes total number of variables is 6. That is what both independent and dependent variables. See, this is the dependent variable. R is the dependent on these independent variables. Now we will going to write the dimensions for all these things. This one I explained so many times, as well as one more times I am going to explain write this one. Now first we are going to write the dimensions of all these things. The resistance force R. I'll write the dimensions of resistance force R. What is the dimensions of, just I will take the rough work for here to write the dimensions. Resistance force. The force unit is Newton, and this can be written as kg meter per second square. So I can write this is kg means m, meter means L, second square is T minus 2. So the resistance force, the dimension is ml minus ml T to the power of minus 2. T to the power of minus 2. Next, dimension of L, length, meter. Meter means L only. L only. Velocity. Velocity, the unit is meter per second. Meter per second. Meter per second. So meter means what? Length. Second means what? T minus 1. The velocity v is equals to L T to the power of minus 1. Next, viscosity, mu value. the unit of viscosity mu means what? Pascal second. Pascal second. Pascal means what? Newton per meter square into second. Okay, then Newton means what? Kg meter per second square. Substitute here. Okay, I will do that one. Newton per meter square. Newton means what? Kg meter second square whole divided by meter square multiply by second. So second is going to cancel. Meter is going to cancel. The next thing is the obtained as kg. This meter is go to the numerator divided by no, not numerator, kg. This multiplication, cross multiplication, kg meter per second. Okay, one more time, meter second is going to cancel. 1 meter is left out in the denominator, then meter into second, so kg meter per second. So the mu becomes kg means what? M. This means meter is L minus 1. Second, if we go to the take to the numerator, T minus 1. So the mu becomes M L minus 1 T minus 1. Next, rho. Kg per meter cube. Kg means what? Kg per meter cube. Kg means mass. Meter is L. If you take to the numerator, L minus 3. Rho is equals to M L to the power of minus 3. Next, finally, K, bulk modulus. Bulk modulus means what? Newton per meter square. Newton per meter square. So for that one, I'm not going to, I will write directly. Similarly, you have to follow this one. I repeated so many times. You have to write this one. So Newton per meter square for this one, Newton per meter square. If you write this one, M L minus 1 T minus 2. Okay. First we did this one. According to the problem, we write this one, and we can write this like. Then we find out the total number of variables. N variables is 6. Next, we have to write the dimensions. Then find the fundamental variables, fundamental dimensions. Find the fundamental dimension. How many fundamental dimensions is there? Fundamental dimension is MLT is there. Completely, if you take this one, mass also is there, length is also there, time is there. So M becomes 3. You have to write M only after writing the dimensions of all the variables. Write the dimensions of all the variables. Check whether all the 3 fundamental dimensions are there. Then M becomes 3. Suppose in this problem the L dimension is not there, then M becomes the 2 in the I'll show in the last problem, in the last problem. Here in this problem there is no mass term is there. There is no mass term is there here. So the M become 2. You have to write this M value, the repeating variables are fundamental dimensions. The M is going to call as the repeating variables. This you have to write after writing the dimensions of all the variables. Here we got it as M is equals to 3. Now, what is the next? We have to find out the number of dimensionless terms, number of dimensional terms, that is pi. Pi means what? N minus M. Here pi is 6 minus M is 3. So pi becomes 3 terms. Pi becomes 3 terms. That one how I can write? I can written as f is equals to, sorry, f of pi 1 comma pi 2 comma pi 3 is equals to 0. See, this is told like that. Okay, this is the steps. First step is written like that. The repeating variable dependent variables depend upon independent variables. We can write this one. We find out the how many variables is there. Later we write the dimensions to all the variables. Then we find out the m. Later we find out the pi terms. Then we write this equation 2. Equation 2. Next we have to go for the repeating variables. That is the very important term. Each pi terms contains what? Each pi term contains m plus 1 terms. M plus 1. What is m? M is the repeating variables. Repeating variables. Here how many repeating variables is there? 3 repeating variables is there. How can choose the repeating variables? How you have to choose the repeating? One should be a geometric property, one should be a flow property, and one should be a fluid property. In this problem, which one is the geometric property? Now you come to this one here. Now find out. We have to find out the repeating variables from these things out of 6. This resistance cannot be taken because dependent variable cannot be the repeating variable. So the left R is left out. Only the remaining thing is what? This 5 is the remaining variables. In 5 remaining variables, we have to choose 3 variables. One is the geometric variables. Which one is the geometric variable? In this problem, length is the geometric variable. Okay, repeating variables. One is for geometric property. What is that? Length. Next is the flow property. Flow property is what here? Only the velocity is there. No, there is no acceleration. If the acceleration is there, if you go for the velocity, choose velocity is the flow property. Next, fluid property. Fluid property is what here? Mu is there, density is there. These three are the fluid properties, but we choose rho. Okay, choose rho. Now this is what three repeating variables we choose. Okay, this is the step 1, this is the step 2. Here is the step 2. Finding the repeating variable is the step 2. After finding the repeating variable, the step 3 is this one. Step 3 is we have to write like that. See, pi 1 is equals to L to the power of A1 V to the power of into V to the power of B1 rho to the power of C1. See, this is the repeating variables. See, L, V, rho. This one, and this one is the repeating variable. Next, pi term means what? M plus 1 terms. Here M is the repeating variables I written here, plus one term. One term you have to write R. Next, pi 2. L to the power of A2, V to the power of B2, rho to the power of C2. R is over. Next is one more term into mu. Next, pi 3. L to the power of A3 into V to the power of B3 rho to the power of C3. See, try to understand. Pi means what? M plus 1 terms. M is the repeating variable and 1 is the remaining variables in the total number of variables. You have to write that one. Okay. If it is n is 6, sorry, n is 7. Here n is 6. So you're getting pi term is 3. If n is 7, pi becomes 4. But fundamental dimensions, m is 3. Okay. Now you go to the one more term is left out is what? K. Now I'm going to call, this is the equation okay, I can call this as equation 1, equation 2, and this is equation 3. Now completely this equation you're going to call as the 4. Okay, we did step by step. This is according to the problem you written. Next we find out the total number of variable by just counting all the things. Next we write the dimensions of all the variables, all the 6 variables. Then we count the how many fundamental dimensions are there. Fundamental dimension is MLT are there in this problem. You count that one. Later we find out the pi terms by n minus m, 6 minus 3. So you can write function of pi1 comma pi2 comma pi3 is equals to 0, where pi is what? M plus 1. M is the repeating variable plus one term you have to be take. The repeating variable is should be taken this rules. One should be the geometric, one is flow property, one is fluid property, and this dimension should not be the same. This dimension should be the different to each other, and the repeating variable at any cost should not be taken as the dependent variable. So out of five variables you have to choose whether which one is the geometric property. So your geometric property is their length, and the flow property is there the velocity. Right here fluid property is there. Out of three I taken as the rho. Suppose any one parameter is not present, geometric property is not present, don't worry, leave that one, right? Remaining properties, flow properties are fluid properties, like that one. Okay, later we write the pi terms, we write the pi terms, then we will solve one by one. This is the next step, is a very simple one. After writing up to here is the very basic one. Don't make any mistakes by choosing the repeating variables. Okay. Now take the first equation here. What is the first equation? In the equation 4, the first equation I will take one by one. Take the pi 1, pi 2, pi 3 and solve the equation. In equation 4, okay, just a minute, just I'm adjusting the, okay. In equation 4, take the pi 1 term. Pi 1 is what? L into a power of 1 into v into b power of 1 into rho to the power of c1, L to the power of a1, v to the power of b1, rho to the power of c1 into r. Now write the dimensions of all these terms. Write the dimensions. This is a dimensionless. So the pi 1 means m to the power of 0, L to the power of 0, t to the power of 0. Next, L means what? Here L. Dimension of L is L only. L to the power of a1, v, velocity, L t minus 1 to the power of b1, rho, m, L to the power of minus 3 to the power of c1, r, m, L, t minus 2, t minus 2. Okay. Now equate the power of mlt on both sides. Next, first equate the power of m. Equate the power of m. Equate the power of m in both left hand side as well as in the right hand side. Power of m here is 0, m to the power of 0. Next you go on search where is the m is there. M is there, c1 is there. This one becomes c1 plus here m to the power of 1 is there, m to the power of 1. So c1 is equals to minus 1. One arbitrary power is we find out. We have to find out the a1, b1, c1. See, we have to find out this a1, b1, c1, a2, b2, c2, a3, b3, c3 for these terms. Then you will get the pi terms. Our aim is to next you have to find out these unknowns here. Now just now I found out the c1 value by equating the power of m. Next, equating the power of L. In the left hand side, the power of L is 0. In the right hand side, very carefully write it. L to the power of A plus 1 is A1 is there. This is into, so the plus 1. Here is the 1 is there. V1. L is there, minus 3 into C1. Minus 3 into C1. Next, L to the power of 1 is there. Plus 1. Plus 1. Don't make any mistake. Carefully you do this one. Next, 0 A1 plus B1. C1 means what? Minus 1 here. So minus into minus become plus 3 plus 1. So I can write as 0 is equals to A1 plus B1 plus 4. Or okay, you write like that only. You keep, later you can do the simplification. A1 plus B1 plus 4. Next, MLT, power of t. Equate the power of t on both sides. Equate the power of t in the left hand side is 0. In the right hand side there is no term here, t. Here is the t is there. Minus 1 into b minus b1. Then next here is the minus 2. So b1 is equals to minus 2. b1 is equals to minus 2. Therefore this equation, this one, therefore this one becomes 0 a1 minus 2 plus 4. A1 becomes, okay, A1 plus 2, or A1 is equals to minus 2. A1 is equals to minus 2. Now we found out the A1 value, B1 value, C1 value of this pi 1. Next you write the pi 1. Pi 1 is equals to L to the power of A1 is minus 2. V to the power of B1 is minus 2. Rho to the power of C1, C1 means minus 1 into R. So I can write this equation as pi 1 is equals to R divided by L square V square rho. Okay, this is the one pi term we obtained. In the same way we have to do for the remaining two, that is pi 2 as well as the pi 3, pi 2 as well as the pi 3. Pi 2 is what? I'll write the pi 2 here. Pi 2 is equals to L to the power of A2, V to the power of B2, rho to the power of C2 into mu. Once again you write the dimensions of all the things from the where you note down in the initially, you write all the things. Pi 2 means dimensionless, m to the power of 0, L to the power of 0, t to the power of 0. L means L to the power of A2 into V is Lt minus 1 to the power of B2. Rho is mass to the power of meter cube. Rho is C2. Mu is what? Mu here, m L minus 1 t minus 1. Now equate the power of m and equate same thing, equate the power of mlt on both sides. First power of m, you have to equate power of m here. here power of m. In the left hand side, m is 0. In the right hand side, here to the power of 1 is there, 1 1 1, c2 into 1 plus 1. So c2 is equals to minus 1. Now our next aim is to find out what is the a2, b2, c2. And after finding out a2, b2, c2, substitute this equation, find out the pi2 term. Next, equate the power of L on both sides. Power of L in the left hand side is 0. Here is a2 plus b2, a2 plus b2. Here is minus 3c2, minus 1. a2 plus b2, minus into minus become plus, plus 3 minus 1 plus 2, minus into minus, c2 means minus 1, 3 ones are 3, minus into means becomes plus 3, 3 plus 3 minus 1 becomes plus 2. Okay, just you keep it as it is, later we'll obtain, because here is uh, 3 unknowns is there, you can find out easily. Next, power of t. Power of t, equate power of t on both sides. Here is the 0. Next is t. Where is the t? Is the here, minus 1. Minus 1 b2. Next is minus 1. Minus 1. So the b2 becomes, therefore b2 becomes minus 1. Now here, this equation, what becomes? Minus 1 plus 2 plus 1. So a2 becomes minus 1. a2 becomes minus 1, b2 becomes minus 1, c2 is also minus 1. So substitute the a2, b2, c2 to this equation, this one. So what will happen? Substitute all the terms, this to here. Pi 2 is equals to L to the power of a2, a2 minus 1, v to the power of b2, b2 means minus 1, rho to the power of c2, c2 minus 1 into mu. So the pi 2 becomes mu divided by LV rho. LV rho. Okay. The last pi term is left is this pi 3. Next, similarly you do this one. Similarly, pi 3 is equals to L to the power of a3, v to the power of b3, rho to the power of c3 into k. Okay. Next, similarly write the dimensions. Pi 3 is the dimensionless, so m to the power of 0, L to the power of 0, t to the power of 0. L is just I will copy this one, just I will change the power, that's all. L to the power of a3, lt minus 1 to the power of b3. Next, rho ml minus 3 to the power of c3. Then k means here ml minus 1 t minus 2, ml to the power of minus 1 t to the power of minus 2. Now equate the power of mlt on both sides. First I will go equate power of m on both sides. M to the power of 0 in left hand side. 0 is equals to just you see here, minus 3 into c3 plus 1. So wait. See, not minus 3, sorry, plus 1. See, don't make the mistake, don't go slowly, Don't make any hurry in while solving the problem. In the left hand side, m to the power of 0 is there. You search where the m term is there. Here is the m term. Here m to the power of plus 1 is there. So c3 into 1 plus c3 into 1 only. Okay, plus c3 only. Next, here m to the power of 1 is there. c3 plus 1. So c3 is equals to minus 1. Go slowly. Don't make any hurry in overconfidence like that. You're going to make the mistake. Next, power of L. Go slowly. Take the power of L in the left hand side, 0. On the right hand side, L to the power of A3 plus B3, A3 plus B3. Here L to the power of minus 3 is there, minus 3 into C3, minus 3 into C3, minus 1. C3 means what? Minus 1, minus into minus become plus 3. This becomes what? This becomes 3 plus 3 minus 1 become 2 plus 2. A3 plus B3 plus 2. Next, power of T. We'll solve it. We'll solve this one. We'll solve because B3 we don't know. We'll obtain from the power of T. Power of T. Power of T to the power T in the left hand side is 0. In the right hand side, go slowly. T to the power of minus 1. B3 is there. So minus B3. Where is the T? Another term. Here is it is minus 2. Okay, here is the minus 2. Minus C. Here T to the power of 0 to the power of minus B3. Here T is the minus 2. So B3 is equals to minus 2. B3 is equals to minus 2. After getting B3 is equals to minus 2, here you substitute here. So what will happen? Minus 2. So here what will happen? A3 minus 2 plus 2. Both are going to cancel. Okay. B3 is minus 2. Minus 2 substitute here. Minus 2 plus 2 is going to cancel. So A3 is equals to 0. A3 is equals to 0. Now substitute all the terms A3, B3, C3 into this equation. So the pi 3 becomes L to the power of A3 is 0. V to the power of B3 is minus 2. Rho to the power of C3 is minus 1 into K. So this become 1. Any to the power, anything to the power is 0. Anything to the power is 0, that is 1. Means anything to the power of 0 is 1, not 0. Anything to the power of 0 is 1. In the same way, here is 1. So the pi 3 becomes K by rho V square. K by rho V square. Finally, we obtained all the pi 1, pi 2, pi 3 terms. Pi 1, pi 2, pi 3 terms. Later, the last step is to simplification. Last step is the just simplification. See, here we found out pi 1. Here we find out the pi 2 and pi 3. Just substitute the pi 1, pi 2, pi 3 here in this equation. Equation 3. I will write here only. Substituting pi 1, pi 2, pi 3 in equation 3. That is function of f1 of function of pi 1 is r by rho L square V square, and the pi 1 is over pi 2. Pi 2 is mu by LV rho pi 3 k by V square rho. Yes, V square rho is equals to 0. Up to, if you write this one, that is enough. Or you can further simplify this one. Actually, in the problem they ask relate this dependent variable with respect to the other things. So you take r by rho L square V square in the left hand side. From this function you take in the keep it in the left hand side. You take all the things in the right hand side. You take from the function to the right hand side. You have to write the one dimensionless term, constant term, pi of mu by LV rho comma k by V square rho, because in the problem they tell that relate this r with the other terms. So you have to write up to here is the final step. Later, which one is the dependent variable is there, keep it in the left hand side. The remaining things should be taken to the right hand side with multiply by the one constant term. Then you take r is equals to rho L square V square pi into mu by LV rho into k by V square rho. This is your the final things. So very deeply I explained the one problem from the basic how to write the dimensions also. This one is repeated so many times. Then also I explained all the things in this one, how to take the fundamental number of variables, next m repeating variables, writing this equation, writing the repeating variables, how to choose the repeating variables, then writing the pi terms, solving the pi terms one by one, pi 1, pi 2, pi 3, everything I explained step by step. Then after getting the pi 1 and pi 2, pi 3, substitute the equation to here. After getting pi 1, pi 2, pi 3, substitute in equation 3. Later, further simplification you have to do. Which one is the dependent variable? This is the dependent variable r. You keep it in the left hand side, take other things into the right hand side out of from the function. Then you have to multiply by one constant term. Then you keep the r, you can write r is equals to rho L square V square pi into mu. This is other terms. This is the another pi 2 and pi 3 term you have to write. This is the you have to solve. This is the very simple problems. You have to solve this one. Very important for the examination point of view. Minimum 10 to 15 marks is asked in the examination. So all students go through this video, watch one or two times, try to understand. Likewise, I will solve some more problems. Thank you.